All right, so now we are moving on to lesson 3.2, which is just looking at the equation of a line in general and figuring out how to identify things like the slope and the y-intercept from it, which we will talk about. Now, depending on when you took grade 9 and depending on the teacher that you had, you are going to see one of two things, y equals mx plus b or y equals ax plus b. A and M just mean the same thing. There was just change to the curriculum where we started using A instead, so that makes more sense in grade 11 and 12 when there's other units that kind of use A for a similar reason. The first thing that we're going to do is define slope, which is just steepness of the line. So now when we take a look at this graph down here, we are going to take a look at a couple of different things that we have. The slope is 2 and 4. I know that 4 is greater than 2, so this equation right here should be steeper. So if I take a look between A and B, so it says match the equations with the appropriate line, and how do you know? I know that A is the steeper one, so A is going to be, A is y equals 4x plus 1. Another thing to remember is that we have the plus 1 and the plus 1, which are the same. This is our y-intercept. This is our y-intercept, which is just the point on the y-axis that it crosses. So right here, I can see the y-axis. I can see they cross right here at 1. 1. So that's why our value there is plus 1, because it is steeper. And B is 2x plus 1 because it is less steep. So here's where you can see I tried to go through and edit it and didn't fully edit it. So that should be A. The general equation of a line is y equals ax plus b, where A is the slope or rate of change, and B is our y-intercept, which is where it crosses the y-axis. Awesome. So then in this example, we just have to identify the slope and the y-intercept from each of the equations below. So in this first one, I have no value here in front of my x, so I'm going to assume that it's 1 and my slope is 1. Right here is my y-intercept, so it's plus 6. In this one, you will notice that there is no x value, so that means I have no slope. X, no slope, which means my slope is 0. And here I have -3, so oops, I'm gonna make that green, -3, so -3 is my y-intercept. If I take a look at the next equation, I should have made this a little bit bigger so that you fit right there, but we'll go with it. In front of the x, I have -3 over 4, so my slope is -3 over 4. I don't have a value, so I know it's 0. If I look here, I have a negative, so it's -1. And if I look here, it's -2. So now calculating slope, use your definition of slope in the graph above and write an equation to find the slope. So what we are doing with this one is this is where we are going into A is equal to rise over run. We can see based on this graph that I am taking a look at right here, the difference in my y value over the difference in my x value. So it's essentially difference in my y value over the difference in my x value. This little triangle just means difference. Here, I don't have values, but I can say that it goes from y2 to y1. So my rise is y2 minus y1 over x2 minus x1, because from here it goes from x1 to x2. So say, for instance, I told you that this value was 2, 4, Well, I'm not telling you that. We can pick it up right off the graph. And here was 8, 10. If I wanted to determine what the slope was, I would take a look at my second y value, which is 10, minus my first y value, which is 4. I'm going to put that over my second x value, which is 8, minus my first x value, which is 2. And then I'm just going to do math. 10 minus 4 is 6, over 8 minus 2 is 6, and this can simplify down to 1. So I know based off of this that my slope of this line is 1. That doesn't really look like a 1 though, so I'm going to rewrite it. There. So we're just going to do a couple of examples. We're going to find the slope, the y-intercept, and then the equation of a line. The y-intercept is always generally the easiest to find. I'm just going to bring my finger pen along the y-axis. I can see it crosses right here, so my y-intercept is -2. To find the slope, I'm going to pick 2 points on the graph. So 2 points, always. So going from -2 to, we'll say this one here. A is going to be equal to, this is, oops, 0, -2. This one's 2, 0. So this is x2, y2, x1, y1. And this is going to be y2 minus y1 over x2 minus x1 is equal to 0 minus -2 over 2 minus 0, which gives me 2 over 2, which is equal to 1, which means my equation of the line is y equals 1x minus 2. You could drop the 1x and just give me x minus 2. If I take a look at this one here, again, along my y-axis, I can see it passes through right here. It's a little bit blurry, but that is a 4, so my y-intercept is 4. I generally use my y-intercept as one of the 2 points that I'm picking between. But here, I'm just going to pick a second point. I can see, if I take a look, A is equal to y2 minus y1 over x2 minus x1. And this is going to be, my y2 is 4, 2. My first point is 0, 4. This is x2, y2, x1, y1, and it's going to be 2 minus 4 over 4 minus 0. Now, the reason why you have to make sure it goes in y2 minus y1, x2 minus x1 is this right here. 2 minus 4 is going to give us -2. 4 minus 0 gives us 4. I can simplify that down, and it's going to give me -1 over 2. So my slope is not positive. Notice that this line points down. That means it is a negative slope. So if I look at this, my equation of a line is going to be y equals -1 over 2x. My y-intercept was 4, so plus 4. Now we've got couple more things to do, and then we'll finish up this lesson. This one we can see it's a little bit of a different type of line. We can see that this is horizontal. That does not look like a Z, but we'll go with it. My y-intercept, if I look right here, is 5. There is no rise, so my slope is 0, because when there is no rise, it will always be, or we'll take a look at it a different way for a second. Let's take a look at A is equal to rise over run. My rise is 0. My run at any given point, I could go to here. My rise is still 0. My run is 1. If I went to here, my rise is still 0. My run is 2. We'll say pick this point, so it's 0 over 4. This is equal to 0. So the slope of a horizontal line is always 0. I'm just going to make note of that. Slope of horizontal is always 0. So here, there is no y-intercept, so it's 0x there is a y-intercept, but there's no slope, plus 5. 0x is equal to 0, so we just write y is equal to 5, and that is our equation of the line. Now on this one, we have a slightly different one, where we do definitely have a rise, because of the fact that we have a vertical line. This is vertical. I do not have a y-intercept though, because it never crosses the y-axis. So there is no y-intercept. Now, if I look at my rise over run, say I pick these 2 points. I have a rise of 1, 2, 3 over a run of 0. Now, if you type this into your calculator, this is the one that always gets students, 6 divided by 0, sorry, my calculator didn't turn on, you will get a math error. You cannot divide by 0. So this is what we call an undefined slope. When we write out the equation for a vertical line, you are always going to say x is equal to whatever point it crosses the x-axis. Here I can see 3, so x is equal to 3. Reason being is because any point along this line, no matter how far I draw it, x is going to be equal to 3. If I take a look here, when y is equal to -3, x is equal to 3. If I take a look here, when x is equal to 7, y is equal to 3. If I took a look at, when y is equal to 7, x is equal to 3. If I took a look at y is equal to -1109, it would still be x is equal to 3. Same thing up here with our horizontal line. At any given point on that graph, y is always going to be equal to whatever my y-intercept is. Here we say x is equal to our x-intercept. And here we say y is equal to our y-intercept. All right, so now we're going to compare 2 lines. When we do this, 2 lines are shown on the graph, and we're going to label with their equations. And they're already labeled with their equations. First thing we want to look at is, how are they similar? How are they different? They're similar because they have the same slope. If I take a look, I can see they both have a slope of 1/3. If I take a look at how they differ, they have, and this is a 1/3, they have different y-intercepts. Now, we define this as 2 lines that have the same slope are parallel, which means they will never cross. So if I take a look at these 2 lines, I can see that they don't cross. They will go off in the same direction, but they will never meet each other. They will never touch each other. They do not cross whatsoever. So those end up being linear lines. We're just going to do a little bit of a summary of what we just talked about, and then we will finish up this lesson. The equation of a linear relationship in what we call slope y-intercept form is y equals ax plus b, where a is the slope and b is the y-intercept. The equation that is used to calculate slope is going to be a is equal to rise over run, or y2 minus y1 over x2 minus x1. You can just use rise over run if you have a graph. If you're only given 2 points though, which we are going to do a lot of equations on, you are going to have to use y2 minus y1 equals x2 minus x1. A line that increases, so it goes up from left to right, will always have a positive slope. A line that decreases, so it goes down from left to right, will have a negative slope. Horizontal lines always have a slope of 0. And an equation of y is equal to our y-intercept. Vertical lines always have a slope that is undefined. And the equation takes the form of x is equal to your x-intercept. And parallel lines have the same slope. And other than that, that is all for the lesson today. You will have some knowledge posted as well as some practice work.